Hello friends. In this session, let us go through the question paper solution of VTU June-July 2025 examination of the subject microcontrollers of module 5. Question number 9a. With a neat diagram, write an assembly language program to interface stepper motor to 8051 microcontroller. So this is the interface of stepper motor to the 8051 microcontroller. So you must write this diagram. So 8051, then to the ULN 2003, and then it will be connected to the stepper motor. So this is the programming concept that is related to the clockwise as well as the anti-clockwise rotation. So it is observable that in the question the program is not asked for specific, that is either clockwise direction or anti-clockwise direction. So you can write the program to any one of these cases, but anyhow I will be showing you here both clockwise as well as anti-clockwise direction of rotation. So if it is the clockwise rotation, then the movement of the data will be the rightwards direction. So as you can observe, the bits over here are the one pattern that is moving towards the right. So therefore, if there is a rightward shift, then it is clockwise rotation. Similarly here, leftward shift, then it is a anti-clockwise movement of the stepper motor. So we have to keep track of these values. Start with one value, rotate to the right clockwise, rotate to the left, it's the anti-clockwise. So here we are going to consider the stepper motor can move both clockwise as well as the anti-clockwise direction. For that we have taken certain considerations here. So first thing, we are going to make use of a switch which is connected to the port 2.7, and we are going to represent the switch as SW for representational sake. If switch is equal to 0, stepper motor moves clockwise. If switch is equal to 1, the stepper motor will move counterclockwise. So this is the consideration. So first we are going to have the mapping of the port 2.7 as an input port. For that we are using this instruction, set bit port 2.7. Then we must load a value to the port P1 so that either we can make it as a move towards the clockwise or the anti-clockwise, and that value will be initially moved to the accumulator, and then that value will be moved to the port P1. Then based on the condition of the switch which is connected to port P2.7, we are going to take a decision about either clockwise direction or the anti-clockwise direction, and accordingly the rotation is going to happen. So this is for one part of the rotation, that is rotate left operation of the content, whatever we have discussed in the table. So that is going to be followed over here. If it is the another direction, then that will be the rotate right operation. So here is the rotate right operation, and after each bit shifting, so we must provide a small amount of delay. Therefore we are going to provide a delay routine over here. So that delay between two values will be maintained here, and this is a delay subroutine. So a random delay is being used over here. So there is no particular representation or the calculation with respect to this delay. Further, this is the C program for the same thing, but anyhow C program is not being asked in the question, but for the sake of understanding or further additional information I am providing over here. Same concept is being written in the C program. So clockwise rotation, then anti-clockwise rotation, then whatever ms delay between two values being called, that delay routine is being given over here. So you can have a follow-up of this one. 9b, explain DAC interface with diagram and also write program to generate triangle waveform. So here you need to have identification. So either assembly language program or C program, that is not particularly asked over here. So you can write any of them. So we prefer to go with the C program, which will be much easier for understanding. But anyhow, I will also be providing you the assembly language program. Now this was the interface you have to first write down. So 8051 microcontroller, port P1 is connected to the DAC. So DAC D0 to D7 bits, and then output of the DAC is passed through the op amp, and then finally we are going to get the V out representation. Right? So now let us get into the programming part. So this is the C program for triangle wave generation. So outcome of this particular program is being given over here. You can just verify this with a simulation in the Keel simulator. Right? So it is very simple. You have to make the values to run from 1 up to 254. Then after, once it has reached to its peak value, then start decrementing it. So that is from 254 up to 1, you have to keep decrementing. So one is the incrementing cycle and the other one is the decrementing cycle. So anyhow, I'm not going to make use of a delay subroutine over here. So if you want, you can just include a small amount of delay, which is quite negligible over here. So I have not showed any delay over here, right? So for the same C program, equivalent assembly language program is written here. So I think the better to make a follow-up of the C program. Question 10a. With need diagram, write an assembly language program to interface LCD to 8051 microcontroller. This is for 10 marks. So in the question, they have specified it must be an assembly language program, and then what data to be displayed, it is not given over here. So we can take any data for the display purpose. Now getting into the solution. So first we have to go through this diagram. See 8051 and which port is connected to which pins of the LCD, that we have to clearly specify. And then after, the same is mentioned over here. And then we need to remember what pins is for what purpose, and that is being given as a note over here. Now getting into the assembly language program of this one. So this is the assembly language program, main part we can consider. So in the first set, we have to send the command for LCD, that is 38 0E01, and continuation is there. And here we can observe that. So the sending the command, then a call, command write, and a call delay. These three lines are repeated throughout. Only change, there is a change in the command value. So quite easy to write the program. Now making the continuation for this one. Now again 06 and 84, continuation of the command. So the commands has to be sent in the same sequence. So then after, we need to write the characters onto the LCD display. We are considering two characters for here. So N is one character, O is the another character. So for that, we are sending the N over here, then data write subroutine, then delay subroutine we are calling. Same is being done for the O character also. So we are going to keep this in an infinite loop. Now getting into the subroutines for command write, data write, as well as delay. Now this is the subroutine for command write, and this is the subroutine for data write, and here is the delay program. So delay program, you can have any random delay value. There is nothing like specific value of delay calculation over here. Same thing is being given in C program also. This is additional you can consider. So C program to send N as well as O to the LCD using the delays. For the same question in the C program, this is the solution we are going to have. So first part is the initialization part up to this point, and then in the main part of the program, first we need to send the command. So starting with the 38, then continuation 0E, then 01, 06 and 86. So these are the set of commands we are going to send, and between each command we are going to have a delay of 250 millisecond. Then continuation, we are going to send two characters N as well as O, and between these two characters also we are going to have 250 milliseconds of delay. Then these are the function calls with respect to the command write as well as for data write. So this is for command write and this is for data write. Continuation, we are going to have the standard delay subroutine that we are going to use in C program, and once if it is going to run, it is going to create 1 millisecond of delay. and how much value we are going to pass to this particular subroutine, that amount of delay will be created by this delay subroutine. Question 10b. A door sensor is connected to the P1.1 pin and buzzer is connected to P1.7. Write 8051 program to monitor the door sensor and when it opens, sound buzzer. The buzzer can be sound by sending a square wave of few hundred hertz. So this is for 10 marks. Now here we have to identify the connections first. The sensor is connected to P1.1. So this is the first one. Then buzzer is connected to P1.7, fixed connections. Then we have to make a sense of the door. So the sensor is connected to the door. If the door opens, then we have to turn on the buzzer. And the buzzer is not a continuous sound. It is through a square wave. Square wave in the sense certain amount of on time is there, certain amount of off time is there. That pattern we need to follow. So when buzzer is turned on. Otherwise buzzer will be silent, that is equal to 0. Now let us get into the program of this one. So in the program, so we are using variable sensor for port 1.1, then the buzzer for port 1.7. Then after, the sensor is an input data, therefore we have to configure this one as an input by setting sensor is equal to 1. So this is the initialization part. Then after, sensor will be continuously sensing the data, and whenever sensor data becomes equal to 1, buzzer must be turned on in the pattern of a square wave. Therefore, initially buzzer is set equal to 0 for 200 millisecond and then it is set equal to 1 for 200 millisecond. So this is going to create a square wave pattern. In case if sensor value is equal to 0, door is closed, then it won't execute this part of the program. It will directly come to here where buzzer value is equal to 0. So the ms delay is a delay subroutine that is being written over here, and once if this routine executes, it generates 1 millisecond of delay, this particular for loop being given over here. So if you send 200 to this one, then it is going to generate 200 milliseconds of delay. Right? So this is what the program related to the sensor and the buzzer. But the program is not restricted. So you can have your own program for this one which satisfies the given criteria. Thanks for watching.